Hi everyone, welcome back to SAT 2 Math 2C. So we kind of finished our series of lectures. We spent 3 topics on polynomials, and we kind of got a good grasp of how, in general, we solve polynomial equations. We're going to shift gear a little bit, sort of go into some of the other little fundamental topics before we build up into slightly more complicated topics. So one sort of fundamental topic I want to discuss is this topic of exponents. I'm pretty sure you guys know a lot of stuff I'm going to talk about, but I want to absolutely make sure you guys are clear about the concepts about what we do. So what are exponents? Well, it's a very simple concept, right? If you have x times x times x, instead of writing that like an idiot 3 times, what you do is what? You say, well, that's x to the 3rd power. Right? That's where the concept of exponents comes from. Instead of just basically multiplying a couple things a couple more times, right? Of course, this is not that bad, but if imagine you have x to the 20th, you definitely don't want to write that out 20 times, right? So exponents simply means what? It could be expressed as a way of how many times you're multiplying a number, right? So the way I look at this, any exponents can be written and expressed this way, and this is, this might be a little bit overkill. This is the base, and this is what? Your exponent. You say, well, Lynn, I know this already. I know you guys know this already, right? Just want to establish. Well, what's important to know is, some of the basic rules of exponents, right? If you are multiplying exponents, what do? Well, you add, right, the exponents. Okay? If you divide the exponents, you subtract. Right? So for instance, you have x of 3rd times x to the 10th, you get x of 13th. Right? You say, all right, I'm going to multiply x squared to it. That's fine. You just add another 2, so you get x of 15 out of it. Right? Simple. Pretty straightforward. And the same thing with division. If you have x of 10th divided by x of 3rd, all you had to do is x to the 7th. Okay? One thing you want to make sure, if you are operating with this assumption, you want to make sure what? This is the same. Right? Your base has to be the same. Right? Otherwise, it doesn't make any sense. Okay, you've done that, right? What else? What if you want to raise something, an exponent to an exponent's power? So for instance, what I'm looking at is, what if I have x to the 5th and I want to raise to the 3rd power? In that case, you have x of a times b. Okay? X of a times b. So in this case, it will be x of 5 times 3, or x to the 15. That's it. Right? Very fundamental rules, and you guys know this already. So these are the basic 3. What if we have, let's play it up a little bit. These are always assumed just integers. Right? What if it's negative? What if you have a negative exponent? What does that mean? Negative simply means reciprocal. Okay? So this is actually equal to 1 over, in this case, x to the 8th power. All right? An example of that, if I have x to the negative 6, it's simply going to be what? 1 over x to the 6. Okay? Right? So, again, very straightforward. Right? What if you start to have rational exponents? What do I mean by that? Let's look at an easier one. What if I have x to the 1 over a? All this means it's the 8th root of x. Okay? It's the 8th root of x. So for instance, if I have x to the 1 over 3rd, that simply means it's the 3rd root of x. Let's put a numerical spin on it. What if I have a to the 1/3? It's simply what? Cube root of a, or in other words, 2, right? So, again, fairly straightforward. I can make it slightly more complicated. I can make of x to the m over n, right? What does that get me? Well, we all know I can actually write this as what? X to the m to the 1 over n, right? I kind of take advantage of this rule, right? It says, if I'm multiplying two things, I can just look at this as m multiplied by 1 over n. So it was really raising 1 to the other power, and this is really what? X to the m nth root, right? That's it. Alternatively, I can take this approach. You say, well, it's commutative law. I don't have to do this. I can do what? I can do x to the 1 over n to the m. Right, in that case, it will be nth root of x to the nth power. And these two things are virtually the same. Okay, let's see. Let's use a numerical example. If we have a to the 2/3 power, what does that get us? Well, we can say there are two approaches. I can say it's a cubic root of a squared, which is what? 2. 2 squared is 4, right? Or I can say this is a squared and cubic root. What is a squared? 64. Cubic root of that is 4. So either way, it's fine. Okay? So the way I look at this, I mean, yeah, it's really just, this is the foundation of how exponents work, right? You want to have, know this inside out. Of course, you wouldn't be able to take the SAT2C if you are not really familiar with this, right? This is not a hard concept. It's very simple. It's very straightforward. But these are some of the things that you need to know.